wanting us to look specifically at this part. What I'm seeing here is that this is a reflection over the y-axis. And what does that mean? That means that if I have f of x, right, if this is a singleton graph here, then if this is the other half of the graph, then f of x equals f of negative x, and that is an even function. So I'm assuming here that that is what they are wanting you to do. It's gotta be. It's just gotta be. Don't you think, guys? So that is that one. I guess when I look at this, I'm very inclined, so I was kind of thinking this was more of a step-by-step basis, like this is the answer to A right here, and I was kind of thinking what they were wanting you to do, so I don't know what you guys put, but that was the answer for A, and now if I look at the answer for B, if I were trying to do even is odd, F is odd, sorry, if F was odd, all these points would change. So for example, here I have, it looks like -2, +5, which would mean I have +2, -5. Oops, +2, -5. And if I look at this point then, or let's go to this guy's a little bit better. Okay, so this one is -5, +8, which means that I must have +5, -8, which is down here. And then let's see, what else would I have? If I'm looking down here, right, I have like -0.5, -10, so I'd +0.5, +10. So my graph would look like this-ish. All right, so to me, this would be the odd function then, okay? That would be the odd function. And then for the last piece, if it's neither even nor odd, then you can draw the other half, and you just want to make sure that it doesn't follow the rules of these guys. So you can draw whatever you want, right? So we could draw this. Oops. Sure, we'll make it a straight line now. Okay, so that would be a function that is neither even nor odd. All right. So 3 graphs for that. Okay. Number 4, what do we have here? Is this the last one? Oh yeah. All right. What values complete the table of f is even? Okay, so I do think this is what they want. They want 3 separate solutions to this. So if f is even, what I want you guys to remember is that f of x, so the y value, equals f of -x, so that equals y. So opposite x's give me the same y value. So here you see how I have -5 and +5, they both have to be 7.7. And I have -15, +15, they will both be -5.2, and then -20 and +20 will both be -7.3. This is going to be your even function. So that means you get the same y value for opposite x's. Now for an odd function, so now we're going to do this, we have f of -x equals the opposite of f of x. All right, so what does that mean? That means that plugging in, so an input of -x is going to give you a -y. Okay, so here I have -20, and I have 20 here, So negative 20 goes with negative 7.3. So that means positive 20 is going to be positive 7.3. Okay. And so now I'm going to look at the 15s. So negative 15 and positive 15. If this is negative 5.2, this has to be positive 5.2. So notice I have here negative x, negative y, and this is x, y. Okay. And you can certainly flip-flop it. It doesn't, I just put negative because both of these happen to be negative terms. But for every x, y on your graph, and remember, if you're doing a table, it's just points on your graph. For every x, y on the graph, there's an opposite x, y. So here, for negative 5, positive 7.7, I now have positive 5, negative 7.7. So that is going to be your odd function. And then for neither even nor not odd, you can put in whatever the heck you want. Okay, so for this one, we can do 1, 2, 3. There you have it.